All right, I'm going to go ahead and get started. My name's Faus. I want to thank everybody for coming to the session today. This is now my 8th year speaking at All Things Open. My very first talk that I gave here was when I worked for GitHub, and I gave a talk called Delivery Free of Charge. I used to actually joke that in that first talk that I gave that I went into the room, there were about 60 people in the room, and I sat there and I asked people to raise their hands how many people had heard of GitHub, and only about 8 hands went up in 2014. And now it's amazing where if I ask people who knows about GitHub, who knows about GitLab, everybody's hands go up. So I'm not going to bore us with the sort of blind poll. I assume that you know about Git, otherwise you wouldn't be here wanting to know about Git workflows. A little history about me. I moved to North Carolina after college. I taught at Athens Drive High School. When I taught there, I built a curriculum for Java with some teachers out of Broughton. Our students were the very first students in the world to take the ACM exams in Java. Got to know some very high up people at Sun Microsystems for doing that. After I left there, I went to go work in the private sector. I worked on the operations side, learned a lot about networking, a lot of things I wish I could forget now. And that took me into a realm where I started getting back into developer tools. And I worked for a startup called TogetherSoft in 2000 that was based on Centennial Campus. I worked there for about 3 years. I ended up going to work for CompuWare. Was sort of a field CTO there, ended up going to work for Rail-Inc. in Cary. I was an enterprise architect at Rail-Inc. I left there to go work at Red Hat. And then after that, the big changes were I started my own consulting practice, sort of a rent-a-CTO type model. Did a project at State Farm, Pfizer, Travelport, a few other smaller companies. A lot of the talk today comes out of a lot of those experiences. I've actually been quite surprised. When I was at GitHub, every talk that I gave was around developer experience. And Git has really evolved. Over the last probably 3 to 4 years, I would say a majority of the people that I talk to are actually people struggling on the operations and platform engineering side that are really struggling with infrastructure as code, best practices, integrating security, things like that. And I'm actually a bit upset if anybody in here is a developer that they're not mentoring their colleagues and teaching them best practices. So in this talk, we're going to be talking about some things. I am not going to tell you how to clone a repo. I'm not going to teach you how to create a branch. I'm not going to teach you how to do a commit and a push. This is going to be some more advanced techniques that when you look at it, and I did this with some people a few months back because I was thinking, oh, this is commonplace. People have to know how to do this now. We've got to move on beyond the basics of Git. And when I showed people this, it was just a small little room at a customer, and I just whipped something together, and they were like, we had no idea you could do that with Git. We've been writing scripts and doing all these other things, and if we would have known that we could have done this in Git, it would have been a game changer for us. So, and I also thought about trolling because I know that I've been speaking at a lot of events and some people are now GitHub employees, so I really thought about wearing my hoodie with my handle on the side and then going ahead and getting up and being like, oh, hold on, I'm getting a little warm, and then pull out the GitLab. So understanding platform engineering. So at GitLab, I work with a lot of executives, and one of the things that when I talk to executives and we talk about DevOps, their eyes glaze over. They're like, I don't know what DevOps is. I don't know what this thing is. I hear things I read things in magazines. I read things online, but this makes no sense to me. So when I do talk to them and I talk about what they're trying to do as a business, and when we start talking about their business objectives, then we start having a conversation. I'm like, well, let's talk about how you measure those things inside your organization. And we'll start off with the CFO. I'm like, how do you measure if you're doing well at the end of a quarter? And they're like, oh, well, we go into Oracle Financials and we run this report. And magical, it comes out and it shows us how good we're doing or how bad we're doing. And so I talk about, well, where do you go to get that for your software delivery lifecycle? What do you mean? Don't you just go someplace just like you do with your CFO and just print something out and magically it gives you a report? And it doesn't work that way. So now with a lot of executives, I tell them that if you take what most people will use as the infinity symbol for DevOps, and they talk about all the different stages, and you stretch it out. And now when we start talking about the periphery on either side of that, what we're hearing with a lot of companies is they're creating a team to the left of DevOps called product operations. And then there's a team to the far right of that infinity symbol called platform engineering. So when we think about this, this is a cultural shift that is going on inside of a lot of organizations. They are moving beyond project-driven, task-driven development, and they're moving towards product-driven, value-based development. And anybody here who is doing anything around platform engineering or they work in operations today, you know that this is going on because you're targeting which applications we're going to migrate to the cloud. What does our product portfolio look like? Where are our high-value products? Where are our low-value products? Which ones do we want to modernize? You're going through these talks on a day in and day out basis. You're building value streams around your product portfolio. And this is something when I talk to executives and I say, this is where everybody wants to get to, they're like, and how do I get there? I want to get there too. And I'm like, well, product operations is how I use the data, and platform engineering is how I collect the data. So I need DevOps in the middle with all of the metadata that's created. And I don't care if you're using a tool chain that has 10 different tools in it or you're using GitLab with one platform. It's all the same metadata. So I need to know when an issue got created, when it moved into the backlog, when it went into dev, when it made it to production, when I closed it. I've got a timeline for that. I can build data around how long it took for that particular ticket to get from in scope to production. And then we have all this data around Git, and I can look at, okay, I do clone, and now somebody has access to the repo, and then I go ahead and start measuring things. When was the first push? How many people collaborated with me? How many new commits came after the first review? What does the security profile look like for this? Is it inbounds, out of bounds? Did we do an exception to push into production? More data. The more data that I can collect around that, the better I get at being able to do my job. So I'm actually stealing this slide from an AWS. I redid it a little bit. So this was from a presentation I saw at an AWS summit in Sao Paulo with a bank called Itaú. I love this. They said this is where they are today. And this is most of the customers that I talk to. They're like, DevOps to them is all about automation. Automate, 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 automate. And I'm sitting there going, why are you automating it? We don't know. We were told to automate it. And I'm like, well, are you measuring your automation? What would I measure? How long do the builds take? Are there ways that I could be doing things in parallel instead of in serial? How do you build dependencies? Are you using a dynamic graph to be able to go ahead and say, if this one fails, then I don't want to waste time building the rest of it? No, we don't. No, just hold automate. As long as I get the little green dot that says my build's successful, I win. So this is where most of the people are today. They've got applications, they've got their platform, then they got engineering operations. In the middle, Itaú had this as ITSM. ITSM is where they were in Brazil, sure. I mean, there's still a lot of legacy banking type customers, so I was like, I'll give them that one. But for a lot of the other places in Europe and in APAC and here in the US, this is really DevOps where we're trying to change this. So DevOps comes in here to make this a transitional graph. We no longer think about these. We're trying to get away of thinking of these as 4 different blocks between application engineering, application operations, and then platform engineering and platform operations. Where we're trying to get to is we're trying to get to a level where products is being in product operations. So I can think about all the measurements that I need around my products, and then I use my platform around platform engineering, and I'm using DevOps, and I'm collecting all of that data to measure my ability. This is the new strategic of where our customers are trying to go in 2023 and 2024. Well, what's after 2024? Well, if I get really good at platform engineering and I'm collecting a lot of data and I know where my high value and low value targets are, I should be able to get to the level of moving that platform engineering down. It's a smaller segment, but now I'm pulling in all the data around the security and everything else that goes along with it that I can now move from where we traditionally think about security as being reactive to doing things with AI ML and automatically fixing things from a security perspective. So now I've got DevSecOps is now the scaling perspective to allow me to know I am now figuring out all these things based on the data that I've measured. I can now scale it because I can have things just do it. I don't need to wait for somebody to hit a button. I don't need to wait for an automation script to run. It's going to sit there and say, oh, this data, we've seen this 28 times, and here's how we remediated it. And it's just going to go do it. So for us to be able to do this, we've come up with 4 different value statements or value streams. So improving developer onboarding and efficiency, building high-performing teams. These are on the product operations engineering side. Then on the operational side, we talk about securing the software supply chain and creating a secure on-ramp to the public cloud. I talk to an executive and I'm like, tell me about your budget for the next year. It always falls into one of those 4 buckets. Usually it's all of those buckets spread out with different percentages. And then we'll ask them to stack rank them. And then when they stack rank them, we sit there and tell them, okay, look, who's driving these initiatives? Because I got to talk about the people that are going to be in charge of this. Too many times they sit there and they say, oh, go talk to the tooling team. I'm like, I'm not going to talk about the tooling team because the tooling team, no matter what I give them, if I automate the process, all I'm going to do is automate it. If I take your process and I give them technology, I'm just going to automate it. If I take the process and I give it to the people, all I'm going to do is scale the processes. If I go ahead and just give them the technology to the people, all I'm going to do is innovate. But if I can sit in the middle and I can get all 3 of these things to work harmoniously against those value streams, I can truly transform your organization. Now, for us to be able to do this inside of a company, what we got to do is we got to figure out what the automation is. What are we going to start doing for our workflow? So when we think about this from a platform engineering perspective, how many people in here are working in operations or platform engineering or solutions architect, whatever you call yourselves internally, right? How many of you work out of a ticketing system like ServiceNow or Jira? Okay, awesome. So we all know that we have tickets. How many of those tickets are defined to you by the project team that owns the code versus being in a siloed environment where it's just operations? How many of you actually work directly with the product teams with your issues? That is awesome. That is how it should be working. If you're able to correlate the work between what is going on with the developers and you're able to see the change that they are trying to impact, you are able to move at the same speed they are to be able to modify the environment that they are going to be leveraging for your platform. So this is what everybody, GitHub, GitLab, Atlassian, we all show the same graph. This isn't new. This is just in our colors. So what we're going to do is you're going to have issues, and sometimes we assign an issue. Sometimes what we're going to do is we're going to go ahead and pull the issue back. When we go ahead and do that, we're going to create a merge request in GitLab, create a pull request in GitHub or in Bitbucket, and then we push the code into it. And then when we push the code, we're going to run through this cycle over and over again until we get to a certain state that everything looks good. And once we have it good, we go ahead and deploy it, and we do all the magic there. So we want to figure out a way that we can go ahead, out of each one of these stages, what is the data that we want to collect? And when we figure out what data we want to collect, we need to know what is the current state, what is the future state, to be able to create a baseline. Once we have a baseline, then we start to measure future state to be able to figure out, am I getting better? Am I getting worse? Then you can start to build all kinds of really cool scorecards, and you get to go, oh, look, I'm a green this week, or I'm a red this week. So that allows you to know where I need to manage. There's a very famous quote that says, you cannot manage what you don't measure. So if I'm not measuring it, there's no way you can manage it. It's a hunch. You think this is the way that it is. So when we go through this workflow, how can I interact with my developers where they are? If I'm actually going to be in the environment where they're creating their issues, their tickets, how can I work with them in their code base to make sure that we're following the same rules of engagement? I want my operations platform team to be measured in the same way that the development team is. If the development team is able to release 10 times a day, I want to be associated with that team that's also releasing 10 times a day. I don't want to be sitting there saying, oh, well, I wrote an Ansible script that got deployed 3 times. No, I was the one who enabled the platform. I was the one who gave them the ability to be able to go and do that release 10 times a day. Sometimes you might have a high-value application that might only get released once a quarter. Great. That doesn't mean that you're a red. I've got to create my own baseline. If my baseline says we take this application based on its architecture, that I am going to release it once every 3 months, you have a baseline. Maybe you get really good and maybe you release in 6 weeks. Everybody gives you a big thumbs up. Oh my God. And then the next time you go out, and the next time it's 3 months. I'm still not out of bounds. My baseline is 3 months. But now I can feed that data back. Now all of a sudden that particular application now all of a sudden becomes high value. Now as it becomes high value, I've got to modify my workflow internally to be able to shrink those windows. So I know what my data looks like across this particular graph. I can now come back and say, now that I am working in the development environment, what I want to be able to do is, what are the things I need to do to enable them to be able to release more frequently? So, inside of GitLab, one of the things that we can do, and you can do, I'm going to do this from a GitLab bent. There are ways that you can do this in GitHub and your GitHub essays, and people will be more than happy to talk to you about how to do this. Inside of GitLab, we have what's called a group. It's a grouping mechanism. You can think of it like folders inside of your laptop. So in that group, I've got Acme Corporation. We will call it the root. That's where the home directory is. And then underneath that, I'm going to create a subgroup called Platform Engineering. The nice thing about this is I can create this Platform Engineering group, and I can assign its own role-based access controls just for that group. So I can give read-only access to everybody else for transparency, inner sourcing, whatever I want to do, but the other people can't come in here and manipulate the projects. So now I can create a bunch of different projects that are small. So I have seen so many people create project templates that try to boil the ocean. Oh, here is my Spring Boot API for EC2 with Postgres, with monitoring, without traceability, not in a landing zone. Okay, there's one template. And then I create all my other templates, and then next thing you know, you got 10,000 templates. Nobody knows which one to pick. Because then they come along and they go, well, none of these actually meet my criteria. Can you go create me another one? So we've got to break it down into its building blocks. And if we're able to break it down into its building blocks, so now, how many people here know what a landing zone is in the public cloud? So landing zones in the public cloud, whenever you get an EDP from your cloud provider, they will tell you that the first thing you should do is create a landing zone. If you don't know what a landing zone is and you want them to bring up landing zone, ask them for a non-prod environment. And they're going to laugh at you. And they're going to sit there and go, I don't have a non-prod environment. The reason why is because everything to them is production. So what a landing zone does is a landing zone allows you to carve out your section of the public cloud that is for your company to deploy into in a secure, risk-adverse manner, however you want to be able to build that landing zone. You can build it in such a way. They have landing zones for financial services. They've got them for high tech. You can tell them what type of company you are, and they will tell you what the right set of configuration things you are. And it usually comes to you as just a template that they modify, and then you just run it. And you only create it once. It's not one of those things that you go back in and modify over and over again. You might make some tweaks to it, but not something that you change frequently. Now, for me, when I worked at State Farm, we actually created landing zones before landing zones were cool. But we created landing zones for a private cloud. So what we would do is we would take an application and we would create what we called pods. So our pods had, there was front end, middle tier, a middleware tier, and then a back end, and then we had a monitoring stack that went around it, and each application got its own landing zone. So that's basically what this is. You're going to get tools like CloudWatch. If you're on AWS, it's like CloudWatch and Tower, and they're going to give you a whole bunch of stuff with SNS and other things for event monitoring and event streaming and all this other stuff. Now, once you get out of a landing zone, then these other ones should be very familiar to you. I've got a Spring Boot application, I've got a Python project, React project. This is where it gets interesting. I am not going to include any of my infrastructure in those projects. Those projects are just the source code that I need for the template of that project. What I'm then going to do is go off and create another set of templates for those things and how I want to configure my infrastructure. So this could be for your database, this could be for EC2, for EKS, for ECS, for Lambda, for anywhere in GCP, for anywhere in Azure, for in your private cloud, for OpenShift. You're going to create little templates for each one of those. And then what you can do is you can create your own little subgroup. So I can have one subgroup, let's say just for Ansible. And that Ansible could have all of my playbooks. And I can have each one of those playbooks individually, instead of me trying to shove those playbooks into the project in the very beginning. So now when I go and I create a new application, so let's say I got a new commercial banking application that we're going to spin up next year. So I create a subgroup for commercial banking. And what I do is I use the Spring Boot application as the back end. I create a template out of that. It's going to go ahead, bring all of my issues, bring the wiki with me, bring everything, all those tools out of GitLab, bring me over into that back end project. And then I'm going to have all of the other ones. Now inside that project right now, each one of those, there's not going to be any deployment associated with those whatsoever in the beginning, because I don't want there to be. I don't want you to start telling me from day one where I'm going to deploy. What I want to do is I want to start writing code. I'm going to deploy probably on my local machine and be testing things. But then on day one activities, we're going to start working with the platform engineering team. We're going to start working with our operations team. We're going to start working with people about how we start collecting this data. So we're going to start adding in the things underneath AWS, GCP, Azure, all these. We're going to start adding them to that project. Ooh, that sounds scary. How am I going to add it? It's already here. Like, you know how most people would do this? What I'm going to do is I'm going to clone the two repos. And then what I'm going to do is I'm going to go and create each file individually. I'm going to copy it. I'm going to paste it. And then I'm going to commit. And I'm going to push it up into the other repo. Way too much work. So, first example. This example, when we go through, I'm going to say I've got my backend API, and all this is available if you take these URLs. I will share this out on Twitter. My Twitter handle is first name, last name. I'll share this deck out on Twitter so you guys can get all the links and everything. So this project is public, so you can see what I've done. So I cloned the first repo into a directory, right? Cloned the second one into a directory. And then I'm going to CD into the top directory. So now what I should see is, if you've got CSH set up, you're going to see the git main. So you're going to see that up there, and then once I have that, I'm going to use a magical feature called git remote. How many people here know what a git remote is? Yes. So we do have some advanced git users. So all a remote is it is just a pointer to another repo. Now, what a lot of people get confused about is when we think about Git, a lot of people think about source code management as code as files. What you got to think about is Git isn't a bunch of files. It's actually a database. So what I am doing with this database is I am going to go ahead. You can think about it as, oh, I've got a whole bunch of data in this Excel spreadsheet that I need to import into Access. For those of us that are old enough to remember Access as a database. So all I'm going to do is I'm going to take the data that is in the EC2, so I'm going to merge that database, EC2 main, the branch, it's EC2 is the folder, and then main is the branch. And then what I'm going to do is I'm going to add this special little thing on the end. If you didn't add that little thing on the end, it's going to sit there and say, these two histories diverge too much, I cannot merge them. I'm going to sit there and say, I know they diverge, but I want you to do it anyway. because I know that there is not a collision between the histories. And there shouldn't be a collision of the histories. That's why we kept them separate in the beginning. So now, when we go ahead and I try to do that merge, I'm going to get a really nasty thing down at the bottom, because Git tries to be too smart. So it's going to find all these files that are in conflict, because it's going to see them as trying to merge together in the same repository. There's going to be the same files. So when we see those same files, it's going to try to merge them together. This is a no-go. Now, if I had two repositories where the file system layouts were completely unique, this would have worked, and you would have looked at the directory and would have seen everything. But two README files, that's going to look kind of ugly, having two README files, and they're on different paths. It's going to look really ugly. So let's throw this one away. This is how we play around, and we go, oh, I need to find a better way to do this. So what I can do is, hey, wait, why did I need to clone that repository locally? Can't a ref just point to a URL? Okay, so why don't we clone the repository first? We're going to CD into there, and then we're going to add the remote to the server. Now, when I go ahead, I've got to fetch the location first. I've got to know what branches exist. I've got to at least get the part of the database that I'm going to merge in. I've got to at least know where it is. So I'm going to fetch EC2, that's my remote location. And now I can merge, and I'm going to be smart about this. So now I'm going to tell it the merge strategy that I want to use. So I'm going to merge -s, and I'm going to say, mine is more important than what is on the server. So choose mine first. And then I'm going to do no commit. I do not want to merge this into a single commit at the end. I want to keep the histories unique, because I need to know everything that's in that EC2 directory. I want to keep these two timelines unique. So now I still need to add the -- unrelated histories. Now that I have this, I do not have, all I've done is I've sort of created those of us that have created shortcuts on our Windows desktops, right? What I've sort of done here is I've just created a shortcut. And what I've done is I've said, hey, look, all these things that I want to put into this database are kind of over here, but I haven't told it to do it yet. So now what I can do is I'm going to do a read tree. And when I do a read tree, I'm going to set a prefix. So that read tree, what I'm going to tell it to do, that .aws, is going to tell Git to create a folder. So now in my Spring Boot application, in that root section, it's going to create a .aws folder. And then what I'm going to do is I'm going to map that to the EC2 main. All of the files that are in there are magically going to show up in the .aws folder. Now I can git commit, and I can say merge everything EC2. I can CD into AWS, EC2, and there it is. Everything is located in there. Well, that would be all well and good, but a developer is going to come over and that is not the way we do it on the development side. You're going to be like, well, I don't understand. This is really cool. Lee showed me how to do this at All Things Open. So if we want to follow the developer workflow, we're going to follow the way that they normally think. So it's going to be the same in the beginning, but before we go ahead and bring it in that directory, we're going to create another tracking branch. So what we're going to do is we're going to create a new branch, and notice I named it infrastructure, so all the developers know that this is not for their bug fix, this is not for their features, this is for me, it's my infrastructure section. So I create this infrastructure, and then I'm going to tell it what I'm doing here, so I'm going to say merge EC2. Now I do everything else. Now I've got all of these changes in the .aws EC2 folder in a branch, which now when I do a push, now allows me to create a pull request or a merge request. So now I can set up a code review, and I can have a conversation with the other people on the team. Hey, we got an EC2 folder. You guys want to see what I'm working on? This is where we're headed. What if they come along and they go, yeah, I don't want to deploy this to EC2. I want to deploy this as a container. I want to deploy this to ECS. Great. Just go ahead and delete the branch. I can go through the same process. Let me go grab that ECS template. Let me go grab the EKS template, and I can bring it in. Now it ends up being a conversation. Oh, the other thing is what if EC2, what if that AMI changes over time? AMIs change over time. I've got new dependencies. I've got new releases. I'm using Ubuntu 18. Now all of a sudden Ubuntu 96 is available. I need to upgrade. So how would I go ahead and do that? I've got a remote. all I need to do is I can go and test in that EC2 folder, isolate it, inside that platform engineering folder, continue to work on that, make it the way that I want it, and when I'm ready and my team is ready to accept those changes, I just follow this process because I already have a timeline that is unique to that folder, and Git will automatically match those shards together for me. Magic. Git is magic. So when we start thinking about all these different workflows, you can start to play around with these. There's going to be all kinds of things that you're going to be able to do that you never even thought about. So now this is what it will look like. So I cheat. I'm not a command line person. Number one, because I hate using personal access tokens and having to figure out how my whole security thing works from the command line. So I just use Tower on the Mac. So this is what it's going to look like locally. So I'm going to have my working copy. I see my change up at the top. I can see my merge EC2 down at the bottom. I've got my remotes. I've got an EC2 remote that is unique. And I've got my origin, which is where the Spring Boot application, the back end repository. I've got both of those sitting inside this repo. If you never delete the refs, you can always just continue to pull from EC2. You can keep that up to date all the time. You just keep pulling that in from that particular location using the same set of commands. You can even create multiple EC2 directories. You could just name them different things. So I could have EC2 lots of memory, EC2 lots of CPU. You could have two different folders, and you could be, maybe you're doing a performance test. The other thing that we can do is we talked about, because it's in a branch, you can see here, now I'm merging from the infrastructure merge EC2 directory, merging it into the main directory. So now I can have a conversation. This is now a merge request inside of GitLab. Now this gives me all of those things that I get, all of that metadata. I can now have my assignees. I can set up labels for it. The one thing that we haven't talked about is, but wait a second. Whenever I hear merge request or pull request, can I do something with that? There's an event that gets hooked off of that. I've got a push event that just happened. That should trigger something for me. Yes, it should. What it should do is it should trigger automation. So if I am building this in isolation, I can go ahead and automate all of this. So inside of GitLab, you would have a GitLab template that would just be how you would go ahead and create the EC2 image. You would run testing on it. You would have all of that stuff, all the good platform engineering stuff around how you manage that EC2 instance. And then what we're able to do is when I'm ready to consume it, because it's in the .aws EC2 folder, that particular GitLab CI file that I've been using to test all of my automation with is now included in all of those files. So what I can do is I just go to the root.gitlab CI file. So on the right-hand side is the one I want to bring in. The one on the left, I can do an include at the top, and I just say, I'm including this from the local directory structure. So I'm going to say, bring in everything .aws, anything that has a subfolder, anything that has GitLab CI in the name. And it'll automatically import all those templates for me. So now you can think about breaking apart all of your different AWS components. So I can have my database, my RDS, I've got all my Lambda functions, I've got my API gateway, I've got all of those things are now segmented, and what I can do is by including that one line, my GitLab is automatically going to run and start executing all of those jobs for me to go ahead and provision all of those resources by adding one line of code. So when I'm able to do this, what you end up seeing is down here, down at the bottom. So when I'm in GitLab, there's this tree view that I can see of all the different YAML files that I am including. So what I see is, because I was in that local and I had the ... it might be kind of hard. You might be like, geez, did I import 10,000 things or did I import 2 things? So this is actually showing me what actually got included. So what GitLab will do is it will merge all of the different YAML files together and give you a preview of that entire collection. And now that I've got these together, what will end up happening is I automatically get all my Terraform. I get my Terraform. Once I build my application, I test my application, I publish my application. That came from the root of all of my stages from my development. Now I inherited all the other stages from my Terraform. So I get init and validate, plan, and destroy. Destroy ends up becoming a manual job, so what I can do is I can provision everything, I see everything inside. And now I can even make that where inside of GitLab I can assign an environment to it. So I can have these assigned to a dev test, I can have it assigned to a stage, I can have it assigned to a production. So I can roll out my changes over time across these exact same set of stages. Okay. So now, I didn't show everything today. There are some other really cool things that we would be able to do. So one of those things is anybody who has ever worked in mono repos, I end up in a situation where there's about 2 gig worth of Git data for the application, and I've got 5 YAML files I want to manage. So the last thing I want to do is I don't want to have to clone the entire repository. So now there's these capabilities. So some homework for you to play around with. There's a command called sparse checkout. And when you do a sparse checkout, you can grab just that directory. So as long as I know that .aws directory exists, I could actually clone and just go grab the .aws directory. Then when I go ahead, I can create my branch, I create my infrastructure branch, I do all my changes, whatever I need to do, and then I can push back into that particular repository. So that's one of the things that you can do. The other things that you can do is we can do things like parent-child pipelines. So instead of me thinking about writing this as one all-inclusive thing for my entire project, I could have a parent that's my application and all my infrastructure, platform engineering things, all of those run as a child pipeline. Those child pipelines can have their own cyclical graphs, can have their own capabilities, they can all be isolated and standalone. Some things may take longer than others. That's why we would do this. I might provision an EKS cluster on Azure, so I need to make sure that I give myself 8 hours until it's done. Nobody got that joke? So deploying an EKS cluster on any of the cloud providers takes forever. So the other thing that you can do is you can also use workflows with those parent-child relationships. So in a workflow, I can say, hey, if I see an infrastructure branch, then I want to include that particular child pipeline as part of my process. So now I can isolate. I might not want to run any of the application stuff. I just want to run the workflows that are associated with infrastructure. So I can isolate which workflows, which YAML file sections are actually getting executed. The other thing is one of the things I talked about in the abstract is platform engineers have a tendency to work on an island. We don't get a lot of people to come in and review our code. We're kind of, just go do it and let me know when you're done. So what we're able to do is we can start to do things like creating a code owners file. This is something that we do on the development side all the time. What a code owners file will do is I can specify directories, I can specify file types, and then I can assign groups or users that have to review that. Now, this is really interesting. So I was an adjunct professor at NC State. And when I taught at NC State, one of the things that I learned is we did a study around pair programming. And now we do a lot of this async, using pull requests, merge requests, things like that. One of the things that's really interesting out of that study is if I get 2 A students paired together, they end up becoming a C student because both of them want to solve it their way and they can't come to a compromise to figure out how to come to the solution. We have this all the time in enterprise too. So the best way to be able to do it is you get an AB, an AC, 2B, 2C, finding the right makeup. I talk about all those value streams, all those other things. I never talk about, we just had this conversation in our room downstairs. I never measure the individual. It's not the individual's fault that they're on a crappy team. So I want to measure the team and I want to make sure that the entire team is a success. That data should be making sure that I know inside that team, what are my baselines and how can I move things forward? So in a code owners, in that scenario, we also found out that if I take most people would sit there and say, oh, that's a great idea. So what I'll do is I'll take a junior developer, I'll make them make the change because I'm a lazy senior developer, and I'll just do their code review. It's not the way you want to do it. Number one, it's actually detrimental to both parties. Number one, the senior devs always have a tendency to solve the exact same problem the same way over and over again. And I can still point to you to the Stack Overflow link that they got that best practice from. Then the other thing is the junior developer, when they come in with a fresh set of eyes. They just came out of university, they just came from another job, they've got probably maybe less experience. They don't have the same tendencies that we have as a senior developer. So I encourage everybody to say, no, your senior dev should be the one making the changes, and then the reviewer should be a junior dev. Do you know when I get a junior dev that they're sort of being asked to do a little bit of everything across the organization? If you are a platform engineer stuck in a situation that you are traditionally the only person on your team, make sure that in your code owners file that you go grab the junior devs and make them review your code. It's only going to make them better. They came in knowing Java, Rust, TypeScript, whatever they learned in their boot camp or in college or whatever. I'm now teaching them how we're deploying the application. I'm teaching them an entirely different side of how we do business. So now that person can come along, they learn something new, they go out, they'll ask questions, and they might ask a question and be like, I don't understand, why is this variable here? And you can be like, oops, hold on. Let me go fix that real quick. So once we have the code owners done for reviews, we can also use branch protections. So what a branch protection will do is, let's say that I go to do a deployment and I run Terraform and that particular job fails, and it's on an infrastructure branch. What I can do is I can say, you are not allowed to merge until I see a successful plan and apply. So those jobs have to succeed before I will allow you to be able to merge that code in. So now I get a way to be able to do automated testing, and I can validate these things. Other things you can do with that too is, if you go off, and one of the last things that I down here are some of the advanced features that are paid features from GitLab, is being able to do things like policy management with the open policy agent. Like, let's say I've got a security group that somebody goes in and tries to modify and wants to open up port 22 or open up all ports around the world in a security group. I can go ahead and I can build a policy around that, and that policy will end up failing on that change reading the file, and I can go ahead and fail that you're not allowed to merge that branch. So now I've got automated checks built into my process, into my workflow, all because I was able to bring that code into the same spot that my developers are working. We've already got the automation, everything built up for the developers. Now I can bring that to the platform engineers. And then the last thing is implementing environments. And I know you can do this with GitHub Actions. You can also do this a little bit with a Bitbucket. The environments are just defined in GitLab, inside your GitLab CI file, and then you set a target for that particular execution. And then when you execute those things, they'll end up going out there and deploying those sets of artifacts in the right landing zone with the right permissions all the time, every time. So with that, I want to thank you all for coming, and I'll ask if anybody has any questions. So any questions? Always one, but there's always, that person's always too afraid to ask it in front of everybody. So I'll tell you what, I know that everybody's probably getting ready to go to their next session. I will make myself available afterwards. I have nowhere to go, so if anybody wants to ask a question, feel free to come up and ask me. Great. Thanks again.